In section 11.6, we work on using and understanding some of the properties of logs. So the big three are these: your product rule, your quotient rule, and your power rule. One of the ones that gets abused the most is this one, the quotient rule. A lot of times people want to treat that as if it's saying something that it's not. That is, they'll say, oh, well, that's log of m divided by log of n. And that's not true. You can't take the log of a quotient, separate it into the quotient of the logs. It just doesn't work that way. It's the difference of the logs. Log of the numerator minus the log of the denominator. So, kind of some bonus properties that I like to include with this are these four right here. And the reason is because they give us a lot of nice simplification. So make sure you have these in addition to the big three. So these are just as helpful. And we'll use those when we simplify a lot of other things. Now we can actually make sense out of some of these if you understand the definition of a logarithm. So what's the definition of the logarithm? Or what's the logarithm saying? Logarithm gives you the power of this base that gives you that number. So b to what power gives you 1? Oh, well, b to the 0 power will give you 1. Or b to the first power gives you b. Now the last two are really expressing the fact that the exponential function and the logarithmic function are inverse functions of each other. What one does, the other one undoes. So an example of something like that where you see something doing something and something undoing it, I could take the cube root of x cubed. When you cube something and then take its cube root, you get back to where you started. Or you could do that in the other order. I could start out with the cube root of x and then cube it. So again, you're doing a function and then its opposite function, or inverse function and then its inverse. So you get back to where you started. And that's what you're seeing here. Now, a lot of the problems you'll face in the homework are kind of similar. They're saying, all right, do you understand that what you're seeing is an example of one of these? So for instance, log base 3 of 3 to the 7th power. Anyone want to hazard a guess on that one? 7. Yeah, thank you. 7. And this one's not quite as transparent. ln of e to the 3rd power. Now, we actually did something like this just on our calculator in the last section. But if you want to understand it, then it might help to write this using its base. What base is implied here when you're dealing with the natural log? Maher? E. There you go. So you got the log base e of e to the 3rd power. What's that going to give you? 3. Just the exponent. These cancel each other out. You're just left with the exponent. Nice. Let's try a different one. 8 to the log base 8 of 5. Do those cancel each other out in some nice way? What do I get? 5. Beautiful. And if you want to understand this a little bit more, let me give you the following example. 10 to the log base 10 of 1,000. And let's work through this one kind of slowly by just working with the exponent. Log of some number is the power of this base that gives me the number. So what power of 10 gives me 1,000? Not 10. 10 to the what? 10 to the 100 would be a Google. That'd be a really big number. 10 to the 3rd power. Right? So this exponent is really just a 3. So I take the log base 10 of 1,000 and I get 3. So that's one function. And then the opposite is doing 10 to some power. 10 to the 3rd power is 1,000. So those two operations, one does something, the other one undoes something. That's why you're seeing that strange kind of cancellation, what it looks like. It looks like these just cancel each other out and you get 1,000. It's a little bit different than that, but it's nothing, well, yeah, it's a little different than that, but that's kind of what it looks like, is that these just cancel each other out. Effectively, that's what they're doing. Now, let's practice some of the other properties of logs, stuff that you're going to need in doing this section. Are we okay with these first four? How about my homers? Out there in Zoom land, doing okay? You with me, Zoomers? All right. Thank you. Thank you. Okay. Let's keep going. So, log base 2 of 2 times 7. This is an example for which you can use the product rule. And just to remind you, here's your product rule. When you have log of something times something else, it becomes the sum of the logs. We'll actually also use this property in the other direction. When I have the sum of the logs, it becomes a log of a product. But for now, that becomes a log base 2 of 2 plus a log base 2 of 7. Now, if you gave me this answer on a test, I'd probably give you 1 point out of 2 or 2 points out of 4. Well, but there's a reason for that. Why? What else am I looking for? I'm looking for you to simplify that first term, log base 2 of 2. What would that equal? I mean, some of you have figured out how to do log base 2 of 2 or log base 6 of 36 or whatever on your calculator. But what does log base 2 of 2 equal? 1. That's just this property down here for logs. When this and this are the same, the base and the argument of your log are the same, then that cancels and it gives me 1. So to get full credit on an exam, what I'd be looking for is 1 plus log base 2 of 7. And just a heads up, there's a problem like this in WebAssign. So again, do that little extra step there. Let's keep going. Let's try another one like that. So log of 10 times x squared z to the 5th. Ooh. All right, so let's look at that. And we should be able to expand this. The log of a product becomes the sum of the logs. So that'd be a log of 10 plus the log of x squared plus the log of z to the 5th. So that's the first step, but there's a couple more to follow. What else can I do here? I'll tell you what, maybe you can remind me, even though it's not written, what base of logarithm is understood to be here? Yeah, there you go. This many, right? That many. 10. So it's log base 10 of those. Now let's just look at that part right here. Does that give us any simplification? Can I now do some simplification? Ashley, what do you see? Yeah. This is just like the one up above. The base and the argument, those both match. So that gives you another 1. All right, good. How about these other two terms? Is there anything I can do with those? William?
I think you put the 2 in the front of the log.
Perfect, perfect. So with these other two, the exponents can come out in front. What did I call it in my video? I had another name for this rule. Sometimes I call it the parachute rule because these are like jumping out in front. So 2 log base 10 of x. I don't have to write the log base 10. It's understood. It's kind of like a square root. You don't put a 2 out in front of a square root. It's understood to be a square root. Likewise over here, 5 log base 10 of z. All right. Nice. Let's try one more like that, then maybe 2 more like that. Then I'll mention a formula you're going to need for the homework. So the next one would be log base 8 of 1 over 8m. I'll start off by recognizing that I've got a numerator and denominator here, so that I can use my quotient rule. Just to go back here and remind you, quotient rule says when you have the log of a fraction, you take the log of the numerator minus the log of the denominator. So in our particular case, that would be log base 8 of 1 minus log base 8 of 8m. Zach, maybe you can help me out. Can I simplify log base 8 of 1? What would they give me? 0. Well done. Well done. So big goose egg there. That's one of our properties back here, right? Log of any base of 1 is going to give you 0. Now the second part, I can use my product rule for that. So it's going to be minus log base 8 of 8 plus log base 8 of m. But I've made a mistake here. Can anyone catch my mistake? What did I do wrong? If you don't see it, it's okay. It's kind of subtle. But there is an oops. The oops is this. If I simplify this, and let me put that in parentheses, then I get exactly what I have here. But if I want to write this expression without parentheses, then that means I have to distribute that negative to both of these terms. So it would be minus log base 8 of 8 minus log base 8 of m. So if I want to write this without parentheses, both of these have to be negative. You got to be careful with that sign there. And now there's one last thing that I need to do, and it's clean up that log base 8 of 8 term. Does anyone know what I can clean that up with? Sarah? What would log base 8 of 8 equal? One more time. Not 0. That'd be if I had log base 8 of 1 would give me 0. What about log base 8 of 8? Some help? 1. Thank you, Maher. What power of 8 gives you 8? The first power. Kind of a quick one here. Log base 3 of the 5th root of x. Oh wait, did I forgive you? Did I forget to give you the property for the logarithm of a root to some power? Oh, that's because there isn't one. All right, I was just messing with you. So what would you do here with something like this? Well, what you would do is you would rewrite this as x to some power. This is where you go back to your rules with what we call rational exponents. You can write that as x to some fractional power. So this would be x to what? I think you said 1/5. Yeah, good answer. Thank you. And now what can I do with that? I guess I should be careful about how I ask those questions. I might get an answer different than I'm hoping for. That 1/5 can come out in front, and you're left with 1/5 the log base 3 of x. Basically your power rule on that. Ajane, question? Okay. So let me see, I'm probably not signed in anymore, but I'll just check it anyways. No, not. Let me do one of the problems that you're going to see on the homework, and it's going to require that you know a formula. And come on, come on. This one right here. It says River City is a growing community, and it gives the growth rate. It wants to know how long until that city doubles in population. This is a very similar problem to something that I looked at with my morning class, and that is, how long does it take an investment to double in the stock market? So let's take a look at this. The formula that you need to know is this one, and write it down. So doubling time. T equals the ln of 2 divided by r. So how long does it take for an investment or a population to double? R is expressed as a decimal. So like on the last test where you had 2.1% interest, you need to put that into this formula at 0.021. You need to put it in as a decimal. In this particular case, ln of 2 divided by, well, they said r was 9%, which for us, we got to turn into a decimal, 0.09. Should be 6 something. ln of 2 divided by 0.09. No, 7. 7.7. Okay. Now, apparently, it's a rather famous question. If you start typing in the average historical rate of return for the stock market, it finishes typing it in for you. In my mind, I don't know about yours, that means that, all right, somebody's asked this question before. Google's like, oh yeah, yawn. All right, somebody else asking this thing? We'll take a look here. Average rate of return on the stock market is about 10%. So what does that mean in terms of your investments? How long does it take them to double if you're getting 10% interest? So if you're using this formula, what would I put in for R? Don't put in 10. What would you put in for R? 0.1. Yeah, put in 0.1 and tell me what you get. How long does it take for an investment to double? Should be about 6.9 years, I'm guessing. Let's take a look here. ln of 2 divided by 0.1. 6.93 years. Let's call it 7 years, just to be easy, right? So, stock market doubles every 7 years. So, when I got out of college, my dad gave me probably some of the best advice he ever did, and that was to invest in the stock market. Set aside some extra money in the stock market. And let's just start out with $10,000. And suppose you invest that $10,000 right away when you get out of college. After 7 years, it's going to double. So how much is that going to be worth then? 20,000. And after another 7 years, how much is this going to be worth? 40,000. And after another 7 years, 80,000. And wow, this is starting to get kind of fun when you get down to here, right? 28 years, 160,000. Yeah. All right, so the alternative for you, Maher, would be that you're going to count on Social Security to be there for you when you're done, right? All right, I see a lot of people are laughing. I don't think that they're with you on that one, that they think that Social Security is not going to be there. Now, here's the cool thing. Suppose you take my advice and you invest early. That means you're around for this to double 1 or 2 more times. What would this next doubling be, Kaisei? Let me help you out there because I was pretty good at math in high school. $320,000. If you're around long enough, these early investments can really gain momentum. It's awesome. You can and will be a millionaire if you invest even a modest amount early and often. It's great. Yeah, don't ask me what to invest in because I really can't tell you. All right? It's like asking me who should I marry, okay? It's a pretty big question. But, all right, let's finish this up with a couple more problems. Let's see. We're going to do some that kind of work in the reverse direction. So, for instance, 2 times log of x plus 3 times log of y. The goal is to write this with one logarithmic term. Now, in order to do that, I need to get rid of these coefficients. So I'll bring that up here. I'll bring that up here. And this becomes log of x cubed. How about the log of x squared? My bad. And log of y cubed. So I'm just taking those terms up into the exponent. Now that I got rid of the coefficients, now I can use my product rule. I'm using it this direction though. The sum of the logs becomes the log of the product. So this is the log of x squared y cubed. And I'll do one last one like this, and it's got a little bit of magic in it. I would definitely recommend doing it the Jeff Parent method on this one because a lot of books and a lot of other websites don't do this trick, which makes it a much simpler problem. -3 log x minus 8 log y plus 5 log z. We're going to do something similar to what we did with the last one. The important difference, though, is that in addition to taking the 3 up into the exponent, I'm also going to take the negative. I'm going to take that whole thing and put it up in the exponent. So all these terms are going to come up into the exponent. I'm going to get this done in 3 steps instead of like 5 or something like that that I see most books describe this with. So it becomes a log of x to the -3rd plus log of y to the -8th plus log of z to the 5th. So we are good on that. All I did was I used my power rule in the opposite direction. All right. This is the sum of logs, or sum of logarithmic terms. That becomes the log of the product. So it's x to the -3rd, y to the -8th, z to the 5th. There you go. I don't know if WebAssign is going to take that or not. For myself, I'm pretty careful on these problems to say, write your answers with positive exponents. So how do I get rid of the negative exponents here? Say again? Yeah, put them in the denominator. So this becomes the log of z to the 5th that had a positive exponent that stays in the numerator over x cubed y to the 8th. Those both come down into the denominator. Boom. Nice, quick, and clean. So, all right. That's a little bonus there stuff for you on 11.6. Have at it.